So when we leave this so-called holy oxidative metabolism, we are tapping into this finer tank of W prime. This, of course, is a very exciting concept if we're able to accurately measure it. And that is, I think, still a bit of a limitation that we are facing today, and research needs to focus on the accurate measurement of it. So this W prime is not rate limited, but it's size limited. The W prime is also a function of the VO2 slow component, VO2 max, and then this sort of anaerobic physiological variables which are related to fatigue. So, in a nutshell, again, the moment when we exceed critical power intensity, we are starting to tap into W prime. If we maintain this intensity above critical power, we will result, when it's expanded, in exhaustion. However, if we go below critical power, then W prime starts to reconstitute itself. So for pacing, this of course is really, really important as well for any sprinting activities. So W prime again is a very, very exciting topic, and given that when we measure critical power we get 2 of those values, then it is a concept that is highly variable for athletes, research and coaches. So where do they approximately sit? Critical power sits sort of equidistant between whether we measure blood or gas thresholds, between the lactate threshold and the gas threshold and maximal aerobic power. And depending on the training status in athletes, that is approximately 70 to 80% of VO2 max. This is really important because given that we are describing here the severe exercise domain, that means if an athlete has a fairly high critical power, i.e. 80% of VO2 max, his or her W prime will be relatively small. And vice versa, if the critical power value is relatively low, the bandwidth of this W prime parameter will be relatively large. That means W prime is inversely proportional to the critical power value. Again, W prime is drawn upon when performing above critical power intensity, and it replenishes when we perform below critical power intensity. So what is that use, generally speaking, for a researcher and an athlete? It is useful for training prescription, again, because it demarcates the boundary between the heavy and the severe intensity domain. It is useful for coaches, going back into the first slide that I showed from Jones et al., to measure endurance capacity levels. It is also associated with exercise performance. It is highly accurate, and that is one of the advantages. It is highly accurate to predict time to exhaustion within the severe domain, i.e. when we work with W prime, we can calculate how long we are lasting at this given intensity, knowing our W prime and critical power values. And therefore it is important for endurance, intermittent and sprint exercise intensities. So this covers a range of attractiveness, I think, which should be, when it's become athlete friendly and when it's performed in the field, can be really, really useful. Let's mention a few important works that are out there, which sort of evolved the critical power research area. To mention here, of course, is Paul et al.'s work in 1988. What he measured is the metabolic and respiratory response when performing at critical power intensity and we're performing slightly above. This was a marginally above critical power intensity. And what Paul found is that when performing at critical power intensity, that VO2 reaches a steady state, that lactate levels out, and so does also the pyruvate level, which was pyruvate. So this was the first definition in 1988, which then said as a key work, it reaches metabolic steady state. Whilst when performing just marginally above critical power, nothing goes into steady state. It's the metabolic disturbance is too high. Important here to mention is the study was limited at the time to 24 minutes, but it was the first study in its kind that demonstrated that it is actually the demarcation point between the heavy and the severe exercise domain. What I would like to mention here is that not many research today is actually performing at critical power. Research that is currently pertinent out there, it is actually performed usually above and below critical power. And this highlights a bit of an issue when it comes down to the accurate determination of critical power and W prime. So Jones et al. In 2008, so let's take a bit of a leap here. He used magnetic resonance spectroscopy, sorry, difficult word for me to pronounce, and he used actually a LAC-Me extension and measured then the metabolic response in there, naming the creatine phosphate levels, pH, and inorganic phosphate levels. And again, what here comes out, he used slightly marginally above critical power and marginally below critical power. And again, we find a steady state. And therefore, this was the first study, because I know that some of my colleagues before him said this critical power determines not a threshold, because it is not just a single parameter, it is sort of inherent